We will now continue looking at the last two examples. We're going to first look at the limit of the cubed root of x minus 2 all over x minus 8 as x approaches 8. So our first part here is that we need to let u be equal to the cubed root of x. So therefore, if we go ahead and want to solve for x, we can cube both sides. By cubing both sides, that's going to allow us to get rid of the cubed root, giving us x equals u cubed. And since we have x approaching 8, we want to figure out what u will be approaching. So we are going to sub in 8 for our x value, so u cubed is equal to 8. So therefore, u would just be equal to 2. And you can do that by taking the cubed root of 8. So we now are going to replace our x's with our u values. So we're going to be looking at the limit of u minus 2 all over u cubed minus 8 as u approaches 2. So therefore, that's going to be equal to the limit of u approaching 2 of u minus 2. Now remember, from advanced functions, we have a difference of cubes. So a difference of cubes, we know that this will then be u minus 2 times u squared plus 2u plus 4. If you're forgetting how to do difference of cubes or sum of cubes, please review that because it is a very important concept that you do understand. So now we're going to look at what we can cancel out. So as you can notice here, we can cancel out our u minus 2's, leaving us with 1 over u squared plus 2u plus 4. We can then go ahead and substitute in our 2 because u is approaching 2. So therefore we have 1 over 2 squared plus 2 times 2 plus 4, giving us 1/12. Now we will continue by looking at evaluating a limit that involves absolute value. So just recall here, when we're looking at absolute values, if I were just looking at the absolute value of x, if we were to draw this visually on our graph, it would look like this. So for any value of x on our left side, on our negative side here, on our negative side, it is going to be the same y value on our positive side, giving us that shape of a U. So just by knowing this, we know therefore that we would have two different possibilities for an absolute value, because we would have the absolute value of -1 would be equal to 1, as well as the absolute value of 1 would just be equal to 1. Therefore, you can see that there's two possible values. So therefore, we know in this case we also have two cases. So case number 1 is that we have f at x is equal to x minus 2 over x minus 2. So when that whole function, okay, of our rational function here, of our polynomial x minus 2, is going to be positive. So that would just be equal to a positive 1. Now in our second case, we would have that f at x is going to be negative x minus 2. Recall again, we see from our graph that we would have two different cases. all over x minus 2, giving us negative 1. So you notice again from our graph that when our value is negative 1, that is when everything is negative, so less than 0. And when everything is positive 1, okay, when our function is positive 1 in this case here, we have that our whole function is greater than 0. So therefore, we actually have a piecewise function here. So what I have is I have f at x is equal to 1 and negative 1. So when it's positive 1, you notice that this is when our x minus 2 is greater than 0. And therefore, it's when x is greater than 2. And when it's negative 1, you'll notice that we have it to be x minus 2 is less than 0, and therefore x is less than 2. Now, since this is a piecewise function, and we know that we would have an asymptote because of our denominator here of x minus 2, we have just that the value is either greater than or less than. Okay, if the value is equal to 2, so if x was equal to 2, our whole function here would be equal to 0. So now what we're going to do is we're going to look at the limit as it approaches 2, both from our left side and our right side. So first we'll look at the limit as x approaches 2 from our negative side, so that's from our left side. And as it approaches 2 from our negative side, we would just sub that value in and see really close to 2, and that would actually give us negative 1. Now if we were to look at the limit as x approaches 2 from the positive side of our function, that is going to give us positive 1. Now since these limits are not equal to one another, we know, therefore, the limit as x approaches 2 of the absolute value of x minus 2 over x minus 2 does not exist.